안녕하세요 여러분, 서울라인 치과 이수영입니다.
Greetings. I'm Dr. Lee Soo-young. I'm with the Seoul Line Dental Clinic. Today, in this master course, we are going to talk about understanding of manufacturing briefly. Manufacturing here refers to digital manufacturing. As I mentioned a number of times, there are 4 basic equipment for digital dentistry. The first one is the scanner, a model scanner or intraoral scanner, and the scan data needs to be utilized to fabricate prostheses or devices. That's the software. Up to here, it's CAD. We use the word CAD quite a lot, and the post-processing involves milling or 3D printer. That's the manufacturing part. So with this, we manufacture these things, frameworks, wax patterns to fabricate crowns and bridges, surgical guides, and clear aligners, which is very popular these days, and splints. So these are manufactured. And today I'm going to focus on digital dentistry, digital manufacturing. Definitions: CAD stands for computer-aided design. It is designing work aided by computer, and CAM is not very well known to dentists. What is it? It is computer-aided manufacturing. Manufacturing is required. There are only 2 methods in any industry. The first one is sculpting, the reducing, carving, or milling. A painting is 2D, and the 3D sculpture is to be made using sculpting. The unnecessary parts are carved out of a stone, and that is called sculpture. The other one is modeling. When we make a porcelain or a bust, we build up with materials such as clay to make a bust. And the process is called modeling. If you apply digital dentistry, sculpting is called milling. And 3D printing is the building up part. So we used to call the printing RP in the past, but the word is not used any longer. When it comes to the 3D printing, we use a special equipment like this. We usually use it to fabricate temporary crowns. So this is the modeling, and the other one is milling, carving out. It is not necessarily a marble, but dental material is carved out, milled. And milling is performed using a burr. Compared to analog manufacturing, and there are 3 benefits when it comes to digital fabrication, standardization of processes, and the failure rate is very low. Using milling or printing, I have hardly experienced failures. Of course, you need to do accurate setting, and the work is repeatable, which is very important. And let me go over one by one. The first one, standardization can be enabled. Let's take an example of making a gold crown. It starts with wax up, and making a model wax up is different depending on lab technicians. Their skill and know-how are different. Investing, burning out, casting, all the process is dependent on the skill level of technicians. Depends on who does the work. CAD/CAM manufacturing is dependent on input data. The input data was not very good in the past. With the advancement of digital dentistry and utilization in clinical setting, digital data has become very accurate, and accurate data is consistently provided. If you do it manually, even though you are skilled, manually the work is reproduced. So it depends on the condition of a person, the technician. If I do the casting, if I had a drink last night, it would be different. But digital dentistry produces output very consistently. Because of the standardization, if you compare these two, we experience failures in casting. I experienced the failures when I was an intern. I did the sculpting and casting, but the output like this happens. This is a little bit severe, but margins have air bubbles and the failure rate is not low, and you need to do the work from scratch. You can also have failures when you do the digital work. For example, when you use ceramic or zirconia during milling burr would be defective, or it can be worn down after a long time use. The milling burr can be bent or worn down, and the failures can occur. But that can occur very rarely. The probability of failure is very low, which is very big advantage. So it relieves you of the stress. In the CAD and the post-CAD processes, there's hardly any fear for failures. Third, the work is repeatable, which is my favorite part. I think once it is designed, why do you need to repeat it? But sometimes we encounter the need. For example, we make beautiful zirconia crown over an implant. Implant crown is not usually cemented using the final cementation. Many doctors use a preferred method so that the crown can be detached using materials such as a temp bond. For example, a patient chewed a very sticky food and a tooth came out, and the patient threw it out without knowing the tooth came out. And the patient calls the clinic and he lost the tooth. If you use the analog approach, what happens? This is a very difficult situation. The patient should visit the clinic and you need to start from rubber impression taking. All the process should be repeated from scratch, but in our clinic, when we receive such a call, we say it was made of zirconia and it would take a day to fabricate the tooth, so you can come to our clinic tomorrow. And we make an appointment for the next day, and we brings out the patient information from our hard disk. We just need to repeat the milling and sintering, so it is repeatable, very big advantage. And we can, with the same CAD design, we can mill with PMMA and with zirconia. Us making a bridge or others with PMMA is easy and cheap, just a couple of bucks. And it can be tried in the mouth of a patient and temporarily it is cemented and let it be used for a certain period of time. For example, if it is an implant, the sit-down can be checked. Case of a natural tooth, we can check any symptoms, discomfort on the part of a patient while using it. If the patient is satisfied, you can use the same data and print it out with zirconia. If there is something uncomfortable with the temporary, before we print out zirconia, by modifying the CAD a little bit, we can do the printout again, which is a great advantage. Let's have a look at it one by one. 3D printers. There are two from Austin. I will go over it later. PMMA, temporary crowns made of resin, polymerized resin. We can use 3D printing for temporaries and even permanent dentures these days. It obtained approval for such use. 3D printers are used quite a lot to print models like this to check custom abutments. It is a little bit different. 3D printing is used for some devices or during the interim processes. Final restorations to be set in the mouth should be milled. Zirconia or ceramic, or sometimes for custom abutment rod processing, milling should be used. Table shows the summary of Austin products. The 3D printers, these two, as I said before, and there are two types of milling machines, 4-axis and 5-axis. I will not go into the details. These are for temporary fabrication, and the milling machines are for final, because this is zirconia, ceramic, or hybrid ceramic can be used. Next, more details about 3D printers. Materials are built up. Let me show you the process. The materials are indicated like this, but usually it's a resin liquid, polymerized resin, which is built up layer by layer. To make a tooth, it starts with the root tips, and layer by layer, it's built up. One layer at a time to build a tooth. It uses a CAD and built up using a 3D printer. After fabrication, post-processing should be performed. Sprues need to be removed and post-curing finishing should be performed. 3D printers, there are so many, a variety. In dentistry, we usually use these 6: FDM, SLA, SLS, DLP, LCD, and PolyJet. And I don't have time to go over them one by one. Austin uses DLP and LCD in general. DLP and LCD types. Four resin types are available from Austin. This is a comparison between LCD and DLP. We have similar functions, but this is used for high volume work, and this is to fabricate a surgical guide or a temporary while a patient is waiting, so it is used to fabricate devices fast. Time and the pros and cons. I will go over this in more details in offline lecture. Milling. Milling is carving out using burrs. Milling, the burrs need to move, usually in 3 axes, and there is a disc material holder, and the holder can move in 4 axes or 5 axes. So this is how they are milled. That's the types of milling. Types of milling machines, a shape of materials dry or wet, 4 or 5 axes. It is a little bit complicated, and I will talk about it in a lecture. When discs are used, the 5-axis milling machine is used. This is used often to mill final restoration with the zirconia or temporaries with the PMMA. Dry or wet types. Here, water is sprayed and there's no water, so this is the dry type. And when water is sprayed on, it is a wet machine. Why do we need to use water? Because of heat generation, only for milling ceramic. Zirconia is like chalk. Zirconia or PMMA milling doesn't generate heat. So when heat is not generated, a dry type is better for milling, and when heat is generated, water should be used. Number of axes, 4 or 5. A burr spindle moves X, Y, Z in 3 axes. In 4 axes, there is 1 more axis besides X, Y, and Z, and 2 more when it comes to 5 axes, with axis A and B added. I will talk about this later separately. This is Austin 1 mill, 4 axis and 5 axis type. They have pros and cons. Ceramic can be milled with the 4 axis. 5 axis can mill hybrid ceramic. It can also be milled by the 4 axis machine, but general ceramic cannot be milled by the 5 axis machine, which is much better for zirconia or PMMA milling. So 4 axis is fast. In 20 or 30 minutes, these can be made. This is for inlay, onlay, and single crowns. And Emacs can be milled pretty well. The precision is plus minus 5 micrometer, very precise for restorations. And these 3 can be inserted together, which is an advantage. So those 3 can be milled together. These are the materials that can be used. For 5-axis machine, discs are used. Zirconia, PMMA are used quite a lot, and also hybrid ceramic and wax for testing.
위해서 캐스팅하는 용도로도 쓰고 있습니다. 사실 선생님들과
I have so much more to talk about with you, and due to constraint of time, 15 minutes, I couldn't go in depth. And please come to my lecture and let's have an in-depth discussion on this topic for 2 days. Thank you for your attention.
감사합니다.